The first 4 questions on this lab are all on the same page in the workbook. They're all in Beyond the Numbers 2.6, and they're all on page 146. The first 3 come from Exhibit 2, which begins on page 145. That's where the box is, but all 3 of the questions are at the top of page 146. For the first question, I think the best thing to do is write the answer out in list form, to list out the possible samples. If you're going to use abbreviations, that's fine. Just stick to the conventional ones. R for Republican, D for Democrat, that kind of thing. In number 2 and number 3, for both of those, the answer is a single fraction. There won't be any partial credit with those questions since there's nothing else to write out. The 4th question is also in Beyond the Numbers 2.6, a little bit farther down the page on page 146 in Exhibit 3. The population shouldn't be too bad, just make sure you're as specific as possible. So use everything you can use there. There isn't a whole lot of wording to work with, but use everything you've got to write out what the population is. Beyond the Numbers 1.14, Exhibit 1, Question 2. So the Exhibit 1 box is on page 45, but Question 2 is at the top of page 46. So you want to find 2 reasons why the inference might be compromised. There are more than that, but 2 is enough, and if you give more than 2, then the first 2 are going to be the ones that are graded. The one thing that I will say is that the different sample sizes is not a correct answer. So where it says subjects as a subheading, and then 40 undergraduate students were enrolled in online courses, 59 in in-class courses, that's okay that the sample sizes are different, so that's not a reason why the inference might be compromised. There are a few others, though. Some of them have to do with confounding. Some of them maybe have to do with how the students ended up taking either an online course or an in-class course, who made that decision. So was that assigned to them, or did they get to pick it themselves? I can give you an idea of what I want as far as the confounding, or what I think you should look for with the confounding, using Beyond the Numbers 1.15 Exhibit 1, which I have right here. There's a screenshot of Beyond the Numbers 1.15 Exhibit 1, and there are a bunch of confounding issues in here. One is that the 2 groups of students come from different years. One's 1997 and one's 1999. They go to different schools. We have a Los Angeles school, we have several Orange County schools, and if they're going to different schools, they're going to have different teachers. So certainly the possibility of confounding there, right? If the idea is that you would generally want things to be similar, except for with respect to whatever your explanatory variable is, it seems like you could get a big difference if they had different teachers. And just going to different schools by itself is probably a big difference as well. One group only had automated instruction, and the other group had automated and traditional instruction. And then the grade level's never specified, so that's a possible source of confounding. Right at the very end of that exhibit, it says, concepts usually not introduced until 6th grade. So all that we know right now is that those students aren't in 6th grade yet. But what if one group is in 4th grade and one group is in 5th grade? A 1-year difference at that age is going to be enormous. So that is a possible source of confounding. So look for those with that question from Beyond the Numbers 1.14. And then also you might want to look at how the students were ending up in the courses. So if they were picking it themselves or if it was being assigned to them randomly. However that was being done, look for that. Beyond the Numbers 1.21, Exhibit 1, the first question. Really, here you're just matching up the letters to the numbers, and the 2 that are already filled in the table, I think you can pivot off those to get the rest of them. Writing out the answer, I think it's just 1, then whatever letter goes with 1, 2, then whatever letter goes with that, and so forth. On the back, where question 2 is, it's something where you have to arrange the 2 crops, crop A and crop B. The best way to put that into a Word document is probably to use a table. You don't have to, but that way you don't have to worry about any formatting issues or anything. The next 3 questions are in Beyond the Numbers 2.22. The 3 questions are on page 186 in the workbook, and you have to use the text on the first page, page 185, to answer them. The text describes something called the empirical rule. The 95% rule that's in our book is 1/3 of that. It's the second part. The other parts are that if you have a symmetric and bell-shaped distribution, about 68% of the data will be within 1 standard deviation of the mean, and about 99.7% will be within 3. For the 3 questions, if you look at the green box at the top of page 186, it's not stated explicitly, but assume that mu, the mean, is 15. You essentially have to do the same procedure for all three questions. You have to identify how many standard deviations away from the mean each value is, and then you apply the picture on page 185 for those values, or in the case of number 3, that one value. Here's a question that's not one of those three, but it's virtually identical procedurally. I copied the wording as closely as I could and changed the numbers to 7.5 and 12.5. 7.5 is 3 standard deviations below the mean. If the mean's 15, the standard deviation is 2.5. 12.5 is 1 standard deviation below the mean. If you go to page 185 and look at where mu minus 3 sigma is, that's where 7.5 is. Mu minus sigma, that's 12.5. If you add up the percentages in between, you have 2.35% plus 13.5%, which is 15.85%. And that's the answer. And that's the procedure that you have to use to answer the 3 questions and beyond the numbers 222 that you have to do. If this example here makes sense, then those 3 questions are going to be pretty straightforward. The next question involves computing the expected value for a discrete random variable. This follows along exactly with the way that we covered it in class. If you follow along with the examples in the notes, if you follow along with the examples that were on the worksheet that we did in class, I think this one should go pretty smoothly. Question number 12 is just simplifying a combination, and it's one where you have to show all the work. I brought this up in class a little bit, where I kind of said if you want to go ahead and ignore writing out the first step, which is canceling out the big factorial in the denominator. So if you just want to jump to right after that, where you'd have the smaller factorial in the denominator expanded out, and then whatever is left in the numerator expanded out, then cancel out whatever you can, and then from there you're just going to multiply to get the answer. That's fine. Questions 13 and 14 are about binomial probabilities. 13, that's all it is. It's just computing a single binomial probability. 14 involves computing a binomial probability, but you have to get the expected value first. So part A, the expected value, you will not get an integer for that, and don't round it off. Rounding it off is incorrect. So whatever you get, just leave it alone, and you need the answer in A to answer B correctly. Part B in number 14 should be longer than number 13 is.